Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your genes. I'm Ian Woolf. On this edition, I speak with Michael Widjaja about cleavage in bacteria, and later with Kate Wilson about a virtual Penrith Observatory. But first up, here's the news. Drunk Mice for Science, a collaboration between the University of California, the University of Southern California, the California Nanosystem Institute, and Nankai University in China, have developed medical nanotechnology to treat alcohol poisoning that could also reduce hangovers. They hope to prevent the liver damage that goes with alcohol abuse. Until now, all alcohol poisoning treatments have relied on the sufferer's body's own enzymes. The team first got mice extremely drunk. You can picture the mice eating tiny kebabs late at night. They infused the drunk mice intravenously with two types of nanocapsules. The first nanocapsule contained two enzymes to convert alcohol into acetaldehyde. The acetaldehyde is one of the metabolic waste products that gives you a hangover the next day. Acetaldehyde causes headaches and vomiting and makes people blush after drinking. The second type of nanocapsule contained enzymes to convert acetaldehyde into acetate, which is much less toxic. The nanocapsules found their way into the mouse's livers, where they worked as reactors to process alcohol almost half again more quickly than untreated drunk mice. The mouse's blood alcohol levels were 45% of the untreated drunk mice after 4 hours. The treated drunk mice woke up more quickly than the untreated drunk mice. The next day, the treated drunk mice had very low levels of acetaldehyde in their bloodstream, but their livers had added a little fat. So these enzymes aren't a complete protection against liver damage from alcohol. The mouse studies have just been published. They're now checking the nanocapsules don't cause any surprise side effects. Trials with humans should start within a year. In the meantime, the researchers ask people to drink responsibly.
The acetic acid molecules and the molecules of ethyl alcohol, not acted upon immediately by the liver, pass on through the veins to the heart. The heart pumps this blood containing alcohol and the acetic acid into the arteries and on to all parts of the body.
The paper was published in the journal Advanced Materials and was titled A Hepatocyte Mimicking Antidote for Alcohol Intoxication. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Bacteria love cleavage. Michael Widjaja is a proteomics biologist at the I3 Institute at the University of Technology, Sydney. He's studying a particular bacteria and how that bacteria interacts with a human host. I began by asking him, are mycoplasma bacteria?
Yeah, so they're actually a simple bacteria in quotations because the number of genes they have to survive is a lot smaller than just your normal typical bacteria that we would know of. And so they're really interesting to work with because they're so small. It's just really interesting to see what they have or what genes they have to survive and how they're able to survive.
And what sort of illnesses do they cause?
So for the bacteria that I'm working on, so it's Mycoplasma pneumoniae, it causes pneumonia in humans. And so it doesn't really affect adults too much, but mainly targets immunosuppressed, the children and elderly.
What are you working on with it? Are you looking at a vaccine or a way to kill it, or what are you researching?
So within that, I'm looking at how this particular bacteria interacts with the human host. And so I'm looking at its proteins. And so these proteins are tools that bacteria and all cells will use to do any sort of job. And so I'm seeing what proteins does this bacteria have to cause infection, or how does it defend itself against the human immune system and antibiotics? Just what proteins will it use during disease?
And how does it defend itself from our immune system?
So what I found during my research here at UTS is that this particular bacteria has this mechanism where it can multiply the number of proteins it has from that one protein. So instead of having one protein to do one thing, it can multiply these proteins and will have 3, 4, or 5 to do the same job. And so this mechanism of how it can multiply is called cleavage. And so this essentially allows it to have one protein to do several different things.
So the cleavage allows it to get creative and create entirely new proteins that you weren't guarded against.
Yeah, so because it has such a small number of genes, it kind of compensates for that with this cleavage. And so now it has, instead of such a small number of proteins from these genes, it has a much higher number, and so it can do a lot more tasks that usually you wouldn't expect it to do.
So how is the cleavage generating new types of proteins when it doesn't have the genes for these new proteins?
Yeah, so it's just the way the protein is structured. So generally you have your protein structure, and the cleavage will come along and cut that into smaller pieces. And instead of completely falling apart, the protein will kind of reassemble itself into new structures. And so that allows it to have new kind of jobs and tools that it can use.
And how did you find out that this is what it was doing?
We weren't expecting this at all. So we were just doing just a normal analysis of what proteins does this bacteria have. And then what we found was it actually has a lot more than we initially thought. And so when we're doing our analysis in the lab, we found that these particular proteins weren't where they should have been. And so when we looked into that, then we were finding that, oh wow, these different types of proteins are coming from this one bigger protein that the bacteria is essentially cutting up.
So it's cutting up a big protein to make all kinds of little proteins that do what it wants to do.
Yeah, so you have this large protein with this giant structure, and then the bacteria will come and cleave these or cut that protein up, and then you end up with all these smaller fragments, which will usually sometimes not work and cause that protein just to become unstable. But the bacteria somehow manage to use these small fragments as functioning proteins.
How does our immune system respond to all these new proteins?
So that's what my hypothesis and what I'm working on next. But I believe my hypothesis is that because it has all these extra new proteins that it's cut, it can kind of use these small proteins as a distraction against the immune system. So it'll cut up all these small proteins, essentially makes all these extra targets for the immune system. And so the immune system will then target all of these small proteins instead of the bacteria itself. So it's kind of like a evasion immune system, yeah.
So how do you observe all this in the lab?
So my field is proteomics, so I'm looking more at the actual proteins itself. And so on top of that, I also do a bit of microscopy. And so I would just use some immunofluorescence microscopy on the mycoplasmas to these particular proteins. And I found that there's a lot more than what there should be looking down the microscope of these bacteria.
And so what's the next step? Once you've identified this mechanism and some of the proteins that it's creating, what do you do now?
So the next step is, so we know that it has this cleavage to make all these extra proteins. The next step is to kind of figure out how does this cleavage come about? How is this bacteria able to multiply these tools? Does it use other proteins? Is it breaking it down itself? And so once we figure out how it actually does that, we can stop that from happening. And then hopefully try and actually stop this whole process of cleavage altogether.
So you're going to try and inhibit the cleavage?
Yeah, pretty much. So try and stop that cleavage, trying to block it. And so that way this will reduce the impact of the bacteria.
So that's more of a kind of antibacterial more than a vaccine type of approach, isn't it?
Yeah, kind of. So we're kind of going more of a preventative approach, I think is like how I should say it, where we're trying to stop the bacteria before it can do too much damage, before it can cause any disease, as opposed to trying to treat it after it's caused an infection or something like that.
How do you imagine you would detect that people have the bacteria, but it's not yet infectious, or it's not yet causing illness?
Yeah, so how would I detect that is it's a little bit hard because this bacteria it takes a while before symptoms appear, and it's not the major cause of pneumonia, it's the second biggest. And so generally you would just do like the usual laboratory diagnostics and then do a test, take a sample, do the test on that, and then that'll like hopefully identify what bacteria it is.
So you've got to identify it in people before it makes the meal?
For my particular bacteria, yes, because it's quite different. What makes this one so different is because it doesn't have a cell wall. And generally the first use of antibiotics is penicillin, which targets the cell wall. So that's generally how the bacteria I work on, the mycoplasma, kind of gets away from that first line of treatment, because it's the antibiotic is targeting something the bacteria doesn't have. So it's not really useful against treating that.
So this would be especially useful in people that have become vulnerable to infection from cancer or other serious illnesses, but haven't yet got it. You could screen them for this bacteria and treat them so that they don't get worse.
Yeah, so potentially if maybe they are immunocompromised or something like that, and that's kind of where this bacteria that I work on shines. Because there's no immune system, it's a lot easier to have an infection, cause an infection. And so yeah, if we could somehow screen that, and then it would be likely that the cause of the pneumonia in these individuals would be from the bacteria that I work on.
So Michael, you've also been in FameLab.
Yeah, so I was in FameLab earlier this year, and that was actually the second time that I've done it. So I did it 2 years ago and then again this year, because I really enjoyed it.
And so FameLab involves getting trained in science communication and getting everything about your research across in just 3 minutes.
Yeah, so it's a full day event. It's a full day program, and essentially the first half of the day they're training you on science communication, how to talk to people, finding the right audience, not too much jargon, so on and so forth. And then the night event, it's quite fun and also quite stressful. You have to talk about your research in 3 minutes. And so you're up against 11 other people around the state. And essentially, yeah, just try and talk about your research for 3 minutes. The key thing about FameLab was that there's no PowerPoint slides. All you had to do was you can either just talk, sing, dance, or use any props. So it's entirely up to you what you talk about or how you talk about it in that 3 minutes.
And did you sing, dance, or use a prop?
No singing, no dancing, but my prop was used juggling balls. So since I was talking about this cleavage in this bacteria and how it multiplies these tools, these proteins, my juggling balls were how it multiplies that. So I was kind of emphasizing how difficult it is. The more juggling balls you have, the more proteins you have from this bacteria.
And this has given you a taste for science communication.
Yeah, definitely. So I've actually really enjoyed science communication from the first time I did FameLab 2 years ago. And then I actually found out that you can just enter again. So I was like, why not? And then so I did. And yeah, so it's just grown and really want to pursue that as a career after my research here.
You did fresh science as well.
Yeah, so fresh science is also quite similar to FameLab. So it's a 2-day event with training similar to FameLab. And then you get a 5-minute talk to a particular type of audience. It changes every year. And then the night event's really cool. It's a really much more relaxed environment where you have to talk about your work in the time it takes for a sparkler to burn. So that's about 40 seconds. And so you can try and cheat and make it last a bit longer by maybe waving your sparkler, but essentially it's a lot shorter, but it's just a really fun event to do. By 2050, it's been suggested the number of deaths from bacteria that are antibiotic resistant will be more than the number caused by cancer. And that'll be at 10 million a year.
So we're looking at research to how bacteria actually survive antibiotics and our immune system. And so my work is looking at cleavage. And so what I mean by cleavage is that it's a mechanism where bacteria multiply the tools they have to cause disease and defend themselves. So if we don't find something soon, just like this sparkler, we're going to run out of time against our fight against them.
And you could do limericks as well.
Yeah, I think that was one of the challenges or surprise challenges for the night, was to do either a limerick or a haiku on your research. And so we only had 15 minutes or so to come up with that. And so, yeah, it was a really good event.
And what do you want to do next with science communication?
So I feel I want to look more into science communication, and especially kind of just do that in microbiology and just towards the general public. So I feel like all this rise of antibiotic resistance and all this fear of germs and bacteria and whatnot, I feel science communication will help alleviate that, because I just feel just educating the public, educating everyone will help reduce the impact of antibiotic resistance, and also kind of just what people are feared of, just help them on like just general topics such as vaccines and all these different diseases and viruses and that.
So we're going to see you with your own YouTube channel?
Yeah, hopefully one day you'll hopefully see me there, and I'll have 5 3-minute shots, maybe even longer, of just videos of general microbiology or research here in Australia, maybe interviews with some scientists. Yeah, we'll see what we do.
Any idea what you'd call it?
Really, I did think about a little bit, something like benchtop to desktop was what I had. I haven't really thought too much more other than that, but yeah, I'll have to think about it. Cleavage is great, and bacteria love it as much as they can. They'll use it whenever they can.
Well, Michael Widjaja, thank you very much.
Thank you, Ian. Thank you for that.
That was Michael Widjaja talking about cleavage in mycoplasma at the I3 Institute at the University of Technology, Sydney. And on to CeBIT. At the Western Sydney University stand at the Consumer Electronics Business Information Technology exhibition was Kate Wilson. Kate is a full-time industrial design student working at Western Sydney University. I began by asking her, "You've built a virtual reality of Penrith Observatory?"
So it took us about 3 months to finally get the working model, but we first started just importing the blueprints and then learning how to work the system as well as how the joining of the walls. So we worked this by going in and looking at the building itself, taking some photos and using it as a point of reference. We also looked into virtual reality such as Sketchfab. So we started by importing it into an OBJ to the actual website Sketchfab, and from here we learned whether the walls work or certain colour schemes work, as well as how to manipulate the VR to do the certain distance and perceptions. So it was a really learning curve as well, and there was 2 of us involved within the project. Another colleague, Rita, she's also a student of Western University, and she's on her last year for that one. So yeah, we were both involved. We did it for about 3-4 months, and we were there it was a pretty easy job for the beginning, and then once we started getting more details into it, it got intensive. Yeah.
And so what area are you going to be graduating in?
So I'm going to graduate in industrial design and specifically majoring into management. So I've done a couple of management courses, as well as lately some more of the architectural as well as some of the robotics. So it's a multi-area field which kind of gives you a little jump into different fields. So I could do architecture and masters for 2 years and it jumps, so I could do like engineering a little bit. So yeah, it's a really good field that's just emerging in the last couple of years, and it's relatively new to the industry. Yeah.
And what software did you use to create the virtual reality?
So we used ArchiCAD to build the building itself, just to get the foundations going, and then to bring the file over effectively and efficiently we used Sketchfab. And within the actual file as well, we use SolidWorks for the telescope. So we use SolidWorks just because we can make the parts individually and make an assembly, and it's very detailed as well as precise because you're using the millimeters of the millimeters. So we did that, and it came through as an OBJ to Sketchfab, which brings the textures. So we could have some really concrete would have that rough edge to it and whatnot. So it was a learning as we go kind of experience, because while there is some out there of video-wise on YouTube on how to do it, it was just trying to understand how it works with what model we were using and whatnot. But yeah.
And so all these different packages you were using, did you know any of them before you started the project?
So I knew SolidWorks because we use that throughout our degree, but I didn't know ArchiCAD or Sketchfab. So it took me about 3 to 4 days to learn ArchiCAD, just to learn what the tools were, how they worked, and when to apply them. And then after that, it took me about 8 hours to have a rudimentary model of just the walling systems. But as I went, I learned how to join the walls seamlessly and have that really nice curvature that it was really, that alone took about 8 hours just to get the curves. But Sketchfab, luckily one of the colleagues on a different project had experience with a little bit of it. So we learnt through there how you can have constricting walls just because of different colour schemes. And yeah, we learnt how to work a new system. So it was relatively all learn as we go. Yeah.
And then when people are actually in the virtual reality, so what you've got set up here, you've got a bit of space where they put on a headset. So what sort of headset are you using?
So right now we're using a Vive. So with the Vive, it's really immersive, so it follows your head movements. We were going to use the Oculus, but it's quite choppy and you have to jump a lot, so it doesn't follow your head. And so we've just gone with the Vive, as well as 5 little hand rails as well. So it just is easy to use, and it's just one button that they click. So it's very easy to set up for someone that's never experienced the technology yet or even used VR before.
And that's the thing. So I had a play thanks to you, and it was very easy to use. You just point where you want to step to next so that you don't walk into a real wall, and you can move around. How many different rooms in addition to the dome with the telescope?
So we've created, with the furniture in there, probably about 6 rooms, and we're in our 7th one that's just a little reconstruction of where we work. So we're just room by room, but we put a lot more detail in the specific ones where the main flow of traffic would be. So lately I've noticed that a lot of people love to go into the telescope room as well as the multi-purpose, and sometimes I can use the objects to even further demonstrate the software. But I have had a lot of people nearly walk into real walls as well. And sometimes they forget and they take off the headset and nearly go into a wall, even seeing it normally. Yeah.
And to add to that, of course, I appreciated that you had places we could stand on top of the telescope to look all the way down, and then you had us go right next to the wall.
Yeah, so I found it by accident, actually. I was just travelling around trying to almost make up like a story to put them through when they were going, and I knew that certain, like the way I'd have to talk, the way I was introducing, the way they had to go, had to be quite simplistic. So I just said they needed to find the flat ground of the areas. It's quite easy to find certain flat areas, so it was just like almost repetitive, but it was simple in its way. So we were able to get the feature going pretty well, and you could explore nearly everything. You just need to find a flat surface, really.
And of course the point of getting right next to the wall is you can put your head through it.
Yeah, so by putting your head through, you can almost get like a sense of being on the 2nd floor or being up really high, so you get that kind of vertigo nearly, and it's really interesting because I've had people react, sometimes bad, but majority of them good, when they experience it and they go, wow, because like they finally get to feel high without actually moving anywhere, and they get to experience what VR is all about. Well, it's been a really good experience. I've had to work out some ways to how to attack different selling points, like how to bring in the VR and whatnot. So the only thing I could say is just because I'm an industrial designer as well doesn't mean that I don't know architectural software. So I can't just be labelled as industrial designer, because now I could also branch out. So there's multiple skills that you can learn, even self-learn, and it just takes a little bit of effort and time, and yeah, you'll get there.
Well, Kate Wilson, thank you very much.
No problem. Thank you for interviewing me. It's a pleasure.
That was Kate Wilson, industrial design student at the Western Sydney University, with her virtual reality of Penrith Observatory. And that's all from us this week on Diffusion. Would you like to hear your voice on radio? Record a voice memo on your phone or use the voicemail tab on the website. We need more people contributing stories to Diffusion. Send your contributions, opinions, helpful suggestions, and donations to science@diffusionradio.com. That's science@diffusionradio.com. And please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate us on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Support the show by joining my patrons at patreon.com/diffusionradio. The news music was Rhinos theme by Kevin MacLeod of Incompetech.com. Sound and fact-checking by Charles Willock. I produce Diffusion, which is broadcast around Australia to 27 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2 NVR in Nambucca Valley, 3 NBR in the Mallee Border districts of Victoria and South Australia, and 7 LTN City Park Radio in Launceston, Tasmania. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 900 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.